Good morning to all. Today we have very important topic related with digital metrology. This metrology in the digital form is being looked after all over the world through the globe, whether it is BIPM, which is working for the pure sciences, and OIML, which is working for the legal metrology, or APEC or the ILAC, which are working for the accreditation programs of the laboratories. Everybody is working in this direction to have the certificates in the digital form. As we are all aware, it is being planned that the certificates should be uploaded in the blockchain so that anywhere in the world they can be seen and they cannot be tampered. Today we have a great scientist with us, Dr. Anjali Sharma. She's a senior principal scientist and head KRC at CSR National Physical Laboratory, New Delhi. She is a professor of Academy of CSIR and deputy head of Planning, Monitoring, Evaluation and International Scientific Affairs Group of National Physical Laboratory. She is a coordinator of the NPL1 program, which facilitates the students across India to use the sophisticated research facilities at NPL. She has more than 18 years of experience in software, including program management, web application development, ERP implementation, database administration, predictive modeling, and data analysis. She has also worked in India software labs of IBM India Private Limited. She completed her PhD, MTech, and B degree in computer science. She is a board member in Department of Software Engineering and at DTU and MIT University. She has been conferred with individual CSIR ERP Project Champion Award in 2013 for exemplary performance by Department of Science and Scientific and Industrial Research under Ministry of Science and Technology, Government of India. Her research interests are in digital metrology, software quality improvement, applications of machine learning techniques in defect prediction of web applications, and empirical analysis. She is a co-author of granted patents in US and has also published articles in international conferences and journals of repute. Welcome, ma'am. We are thankful to you. You have accepted our request to deliver a talk, which is very important topic on digital, because nowadays it is very important. Right now, what we are doing, as you know, as you are basically, you told me digitization, digitalization, and digital transformation. So at this stage, actually, we are in India. I think we are working up to the level of digitization. So how we have to move further, I think it will be very important. Thank you very much. Over to you, ma'am, please.
Thank you, sir. Good morning, everyone. Thank you for inviting me on this platform where we are reaching out to many of our stakeholders and apprising them of what we are trying to do in terms of digital metrology. So, good morning, everyone. It's an online platform, so I understand that it becomes tough to gauge your attention every time, but I'll request you to, if possible, just listen to it and look into the PPT seriously. And in case wherever you are finding any queries and anything, you can raise your hand and we can then and there start discussing, because it is a sort of a workshop or a seminar. Let's not make it monotonous with one single way of communication where only I am talking and none of you. If you have any query at any point of time, please feel free to raise your hand, and the moderators here will help us with the questions and all, and I'll try my level best to answer your queries. If not right now, we can always discuss it offline. You can always email me, call me, and we can have a fruitful discussion, I hope. So starting with the presentation that is for today's scenario, it is digital metrology. Basically, we're covering out what is the national and the international scenario as far as the national quality infrastructure is concerned at India, and what we at NPL are trying to work upon. So in this period of time, I'll be covering basically the introduction part and which are core areas the other national metrology institutes across the world are focusing upon. Some technologies which we all need to think over for this full stack development of this project, which is digital metrology. And what NPLI has emphasized as its roadmap for implementing digital metrology, the challenges we foresee, and a sort of a small summary. We all are aware, like today's seminar itself is what we called as a digital revolution. Just before Corona, uh, we never thought that we all will be meeting on such a platform as WebEx or Gmeet or MS Teams, where we are collaborating and listening to each other for quite number of hours. In today's scenario, everything is becoming hybrid. We any event we are holding, it's getting live streamed as well as the offline participation is there. So everything is coming to a platform where digital is something which has become the lifeline of all of us. Whether it's a small, like even in today's scenario, if our house helps, they inform us with a small message on our WhatsApp, and they'll be able to come or not. So that's the level of digitalization that we are facing. I pay most of them through GPay or anything. Our house help as well. So if everything is undergoing under automation, what is something that comes to your mind? Here I'll request for your questions as well. Like uh, when we look at this device, which is our phone, uh, how is it helping us? And how do you think these measuring devices are actually getting inseparably linked with this digital technology and data processing? Can any one of you just feel free to raise the hands and be able to into it? Are my slides visible again? So I
Yes,
don't
ma'am.
think
It is visible.
so each and every measuring device, like if we are traveling from a train or even if we are traveling from a plane, we get to know the train passes through, and we get to know when we are about to arrive at the station, sitting into the train compartment itself, or our family members are able to look into the portals and identify when the train is going to arrive at that particular station. So even the speed, the average delay time, we get to know when we book a train ticket, what is the probability of our ticket getting confirmed, if it in case it is in a wait list or something like that. Then another example is, so there is some measurement involved, yes or no? How are we measuring? Some distance is traveled, at some speed is traveled, and at what time we are about to reach the destination station. Everything depends on the measuring device and how those measurement devices are communicating centrally. Another very prominent example is this Google Maps that we use in order to commute from one place to another place. They give us that information. If I want to travel from here to my hometown or wherever I want to go, I actually try to find out what is the best time to travel in minimum traffic. How is it that they are logging into all of this information and then presenting us in a way that we are able to think about it? So if we come in terms with the measuring devices, so if I say we as a National Metrology Institute, we work onto the primary standards as well as the secondary standards. So it takes time to let the audience understand what NPL India actually do and how do we do it. So in due course of time, my just focus is that it is very, very important that what all we measure is correct, and this digitalization is something which needs to happen whether we agree to it or we don't agree to it. So with all of these things, big data or the Internet of Things. So when we come to Internet of Things, we say that the sensors are communicating with each other and giving us the information. So if one sensor or two or three sensors, they are not uh, calibrated properly or they're not providing you the proper signal which they are supposed to give, then this becomes a problem in real life when it comes to industry or anything else. Now, even if we take an example of a small screw that we use and the components that are used in assembly of a automobile. Suppose we have car assembly and everything, and we use these things for measuring. And if any of these screw devices or anything, if they're not correct, then how the assembly will happen? And you can understand the impact it is going to have overall to the car assembly. We cannot have a car assembly because एक screw or एक gauge, अगर आपने I can use bit of Hindi as well or no? Okay.
Ma'am, you can continue. You can use this Hindi English both.
Okay. Okay. So
Just to combine both.
yeah, I felt कि अगर हम जैसे अगर हम किसी भी एक कार असेंबली की बात करते हैं, then there are screws and there are different thousands of components that are assembled together to get one car or any automobile thing working. If any of the screw is not as per the measurements that are there, then they're not going to fit in. And in case they're not going to fit in, our whole assembly line may fail. There has been incidences where big automobile companies have called some of their cars and devices. They have brought back from the customers, stating that there was this problem in this device. There was this part is not functioning properly. So anything, if we measure, we have to measure it correctly and with accuracy, such that in long term as well, it works for us. So bringing it to something like a basic example, like if I see this milestone onto any of our highways and anything, if this is the value that oh, sorry. So A20, A200000, this may be a garbage for us as human beings, but this is what the computer understands, or it is a hex code of what is written here, if I say so. So you'll say, Acha, fine. But what you can relate to is this milestone symbol that is presented here. So what does it present here? If I simply say Jaisalmer 90, Lathi 25, what reference does it give it to you? Does it synchronize with you? This 90 can be 90 yards, 90 can be 90 kilometers. Is this 25 can be yards, kilometers, meters, whatever. So until that unit is not associated with it, it does not give us the actual meaning. So any measurement is associated with the context. in physical world, it is not, it's that abstraction of the physical world that we are seeing. So this metadata that we call in today's terms, so this metadata is something that it's Jaisalmer, and this is 90 kilometers. This from this place to Jaisalmer is 90 kilometers. So something where this contextual information also comes into the picture is what this measurement is. Simply measuring anything without giving it a proper context, without conveying the meaning. So this is also a measurement. Like these hex is also a measurement sort of thing. But if it doesn't give any context to it, that this is about this distance that we are about to travel, then this number does not make any sense. So measurement means anything that is measured, but with a context, with a meaning to it. So consumer, as a consumer, I want to know about something. So I have a purpose why I want to know about something. Until unless I don't want to know about it, I'm not a consumer. And why do I want to know about it? So this is something that we say that, okay, this is about the information that we want of the real world. So real world information I need, and I have a purpose of knowing that real world information, and that is what makes the context and the measurement for the consumer side. If I am a provider of this information to my consumer, then I can measure the quantity or related quantity, and I can give it a contextual meaning to it. Like I can give it in the accurate measurement unit to my consumer. For example, we all have customers who come to us asking for a calibration or a testing certificate. So what is the purpose of them asking for us? Because there are, one thing is, as per our national quality infrastructure, they need to abide by some rules. They need to get their things calibrated. They need to get their things tested. So that is the purpose. It is going to run down their businesses and organization is how it is working. And they want to test whatever they're measuring, whatever device they are using into their industry, how it is going to affect, how accurate it is, and how it is going to affect their information in the real world. We, as a provider, we need to give them that specific quantity and statement that, okay, whether it functions as per their understanding or it is not functioning as per their efficiency. So again, after identifying that data, they may want to get accredited as NABL or NABH or whatever. So that's again, when I talk that it is a part of their national quality infrastructure in which we all come. So again, consumer, if they again want to know that how have you derived, like we gave them this certificate which says that whether their the calibration thing that they have provided, it is what is the measuring measured value that we get, and what is the uncertainty into that value. Now, if the consumer in due course of time demands from us, do let us know the data through which you have arrived at this conclusion. We want to have a look at that measurement data itself. And that is how it is going to help them due course of time. When we talk about now industry 5 is also there, and with IoT things, they may be demanding from us the data through which we are arriving at the calibration certificates and testing certificates. So usually what we are trying to emphasize here is that measurement serves a purpose in context. Usually there is a decision to be made, and that decision is based upon the real world quantities, and that information need to allow interpretation of data for that purpose. So the consumer needs information, the provider must offer them an appropriate representation of the measured data, but in the end, the useful representation needs to be prepared such that it is accompanied by sufficient information, so that the end user is not confused with whatever information is being provided, and then it is very much clear. It has got that everything. The meaning of the data is very much clear to the customer. So when we talk about this data and how important this data has become in today's scenario, there are two very important things that we talk about. And that is, if I have something and I can't operate upon it, uh, then it is of no use to me. I need something on which I can operate. Suppose I buy a car, but I can't drive it. Like if I can't drive it, that is my inoperability or inefficiency. But if the engine doesn't start, so the car is not moving. Or if I provide a data to my customer which is not adequate for its task, suppose I provide them the calibration certificate or a testing certificate where the values that I gave, uh, they're not able to do justice, or they're not satisfied with it, or it is not operatable, that the data is not adequate for a task assigned. So number one thing is this operability is very important. Another thing by which we, uh, all the organizations under national quality infrastructure comes, is that it is about interoperability. Whatever data is here, data is there, it needs to be interoperable in order to communicate with each other. So interoperable, हम software engineering में या वैसे भी what we read is that in order to make few modules interoperable, आप पूरा हिमालय एक बार में नहीं चढ़ सकते. So you have to, there are base camps, you travel up to one distance, you stay back there, acclimatize, then move ahead, move ahead, move ahead. In a similar way, if I am a person who can speak Hindi and English only, if there is another person who cannot speak Hindi or English, then how does it happen? How the communication happens? It can happen through gestures, or it can happen through sign language, or we need a translator. We need one person sitting between us, translating whatever I am saying to another person in the language in which he or she understands. So in today's scenario, when we talk about digital metrology, so metrology means measurement of science, and how digital thing is affecting this measurement of science, the efficiency of this measurement of science is actually depending upon the data. And for the data, these two characteristics is very important. One is the standardization, right? We at some level decide that all this data needs to be like this, like this. We are not forcing everyone to be okay. यही चलेगा, इसके अलावा कुछ चलेगा. Because standard is something which gives you a basic thing, like okay, it has to be done like this, but we can decide our own implementation scenario. Like we have this ISO 17025 standard is same, but the way we implement them, it's more or less depending upon our organizational quality quality systems and agreements. Again, everything cannot be done in a one go, so there needs to be a modularization happening. We take some parts, do it, then integrate it. And for that integration, there needs to be a standardization. And these two things happening onto that data, which is operability and interoperability. So we've talked so much about data. And right now comes the point where these digital technologies, in due course of time, will disrupt our measurement infrastructures, in the sense that if today I want to hold a meeting, I want to be here and do those meetings. There are various countries where this mining is a very important business. So they can't, every time they cannot bring out all those instruments like temperature, humidity, and various other parameters that are being monitored for these mining places around, they cannot just bring down those instruments. And they this is so critical that in case any of those instruments get down, so many lives are at stake. It's not only about the financial terms, the human lives are also at stake who are working down there. So they need a solution where all these instruments need to be calibrated remote. Number one. Number two thing is today's just during this course of COVID, the world recognized that we need to get things done and we have the technology. And how best, in a best possible way, we can provide these services to the end user so that with little discomfort or with no discomfort, efficiently we can provide them what they are looking for. So that is how this digital metrology has taken up a very, very good pace in our national infrastructure. And looking into this, here we sit as a National Metrology Institute. And then there are standardization bodies, but we have this thing coming to our BIS, who writes standards, then we who realize these physical parameters, these physical standards. We have our accreditation bodies like NABL, sorry, the B missed out here. NABL, NABH, UCI, everyone. And then we have certification bodies. And until unless whatever is being done, suppose I realize these parameters as per the standards written, then the accreditation body accredit the different institutes as per their norms. But until unless, it's very, very important to have these inspection bodies as well. So this is where our legal metrology is playing such an important role of actually pandering to this. What they say is that jago grahak jago. So they are actually putting into a lot of efforts into inspecting all those uh, places and ensuring that the quality product and services are delivered to our consumers and general public, and that is what we are being paid. So moving forward, here we are managing how we are doing all of this is through 17025. We provide them with their calibration certificates and testing certificates. Now here is what is bringing into picture is, can these certificates be digitalized, not digitized, digitalized? So we as the NMI of the country, there is a very, very important need that we do this physical measurements is fine, we are doing it, but what are the steps that we need to take to contribute this our meteorological know-hows and everything that we have in terms of a National Meteorology Institute, how we can deliver it to our customers down the line so that we give them the best of the services and we provide them whatever is required with best efficiency as well. So until unless these units and quantities are not measured properly, it can result into drastic issues. Uh, there was this NASA Mars orbiter is something where uh, nicely, but one point that they forgot to convert, the unit conversion was not there, and that's how this doesn't work. So again, in software as well, this quantity correctness, it's important. And dimensions and quantities is something that is important. It leads to a chaos if not done properly. So here comes the few definitions that we talk about. One thing is we talk about what is digitization. So a basic step is anything from analog to digital form, and that is something called digitization. Like suppose this here I've shown a typical map. Uh, we have taken that map, scanned it, and put a picture here. So this is simple analog to digital conversion, and this is a digitization. But when we talk about digitalization, it is the process where we are utilizing these digital technologies, and here we are resulting in deeper changes that can alter the core of business models. So एक जमाना होता था जब हम सुबह सुबह 4-5 बजे भी उठ के टिकट की खिड़की के सामने जाके खड़े होते थे, बहुत लंबा लंबा लाइन लगता था, किलोमीटर लंबा लाइन, और महीनों पहले हमें अब सब कुछ पता करना पड़ता था. We were paying agents also for all this effort so that we could get one confirmed ticket to travel. Especially summers में हमें भी summers में अपने नानी के घर जाने का ही भी. Now all that experience has been अगर वो experience में अगर मैं ये कहती कि ठीक है सिर्फ आपका जो टिकट आएगा ना वो पेपर पे नहीं आएगा, वो हम आपको फोटो खींच के भेज दें. How will it help me? मतलब एक लेवल पर ठीक है कि मुझे उसका प्रिंट आउट या मुझे उसको संभाल के रखने की जरूरत नहीं है, मेरे पास वो हमेशा एक किसी फोन में या कहीं पे रहे. लेकिन अगर मुझे उतना ही प्रोसेस उसको संभालने के लिए लगाना पड़े कि मुझे फिर से किसी एक एजेंट को वहां भेजना पड़े, वो टिकट बुक करा के लाए मेरे लिए और वहां वो अपना नंबर दे आए सपोज कीजिए, सो देन it's not changing the whole business model. Here when we talk about digitalization, the example is this our IRCTC online booking system, where I type, I log in, I'm able to see all the trains which are going from my boarding to the destination station. I can book any of it with a click of a button. I can do online payment. Everything is on my fingertip from start to end. And that is what this digitalization is. It's give you the unique experience from one end to another. Another example is the way we book our Ola or Uber or any of the cars that we want to travel from. So this is what digitalization is, and this digital metrology is all about transforming the services that we are providing to our consumers in a best possible way. This will include lot and lot of business process re-engineering, as you could see that एक example लिया जहाँ पे हम IRCTC से बुकिंग ना करा के हम प्लेटफॉर्म पे जाकर भी आज की तारीख में भी करंट में टिकट्स ले सकती. They have not aborted that process at all. But if I want, I can do the whole process sitting here as well. So again, the type of services we are providing to our customers from one end to the another end, as you could see, it involves lot and lot of business process re-engineering as well. It includes lot and lot of interoperability of the data as well. There are many departments that we have to work together to get these things done. In a similar way, this is what the international community has recognized, that how we need to give all these facilities to our end customers. And another typical example is this scanned copy of a map that you have and the Google Map. Google Map is something which provides you n number of services. When we talk, कहने को वो भी map ही है, but it gives you n number of services along with giving you it on your phone. It allows you to decide when you want to travel. It gives you the traffic status. It gives you n number of other services as well. So these n number of services is what brings this into as a digitalization service. And here in this example, this is our national quality infrastructure. And right now, the next part will be that how we into this whole game is getting our things done through international scenario that is changing at all levels. So working down the next part of my talk, which is the international scenario of digital metrology and how everyone across the world has come together for this digital metrology, and they've identified that this is very very important. So many of us might know that we are 6 RNOs under CIPM MRA, and we are here. So see, this blue region is what is called Asia Pacific Metrology Program. So you can see even this Australia, New Zealand, everything here is a part of APMP. And in APMP, we are there are developing economies as well as developed economies. Same is with others. So another one is this Euramet, where all the European nations are there. And then this is EFRIMENS, and GulfMed is something which has come up 2-3 years back. This is GulfMed, where UAE and everything is coming under GulfMed. And SIM is somewhere here, the whole North America and South America. So we will go briefly as to what is happening around these RMUs. So when we talk about these CIPM and everything, so there was this treaty where this is called this General Conference on Weights and Measures, which is CGPM. And then there are various international committees for weights and measures, and that is what we call as CIPM. And under this International Committee for Weights and Measures, we have got various consultative committees. So now if we go recently to this consultative committee's website also from CIPM, you will find that they have made consultative committees for digitalization in length. They have made consultative committees for digitalization in aggregation. So they have specifically made these consultative committees, suppose in length, what can be the effects of digitalization, how it can be done. So there are these consultative committees. And again, that is what we have. Then under these consultative committees, we have these working groups. And again, there is this International Bureau of Weights and Measures. And with BIPM, we have APMP. And under APMP, we come as India or as the National Metrology Institute of India. So the international effort that has gone is that it recognized the need of supporting SI in the digital world, and there is a task group on digital SI, which is called CIPM TGDSI, and there is a working group on data as well. So there has been a virtual workshop we may have attended. They were all free mostly for all of us to go and attend. And recently we have this, if you would have heard of, there is BIPM, we just discussed. Then there is OData, IEC, ILAC sir just mentioned it, he also is there. Then IMECO, ISC, ISO, OIML, everybody came together and presented this joint statement, which is something here that I have given. That they combined together and they said that there has to be a digital transformation in the international scientific and quality infrastructure. So if I go through these points, it's very clearly written that governments, industry, academia, and civil society have been working towards comprehensive digital transformation for many years. An example is our IRCTC and everything. And in so doing, are increasingly establishing systems to collect whatever data they have been collected, they aggregate, analyze, and digital data. Introducing network sensor systems for diverse scientific and industrial applications. The new industrial applications are based on this. And then sharing data at local, national, regional, and international scales. So this is what has happened. Now we as a national quality infrastructure, or when we become a part of a international quality infrastructure as well, we need to come up to these terms. So that's why they are coming together, and there is this CIP strategy also 2030 that is about to come up. And there are when we attend conferences, we attend all these meetings that various working groups and task groups we are part of. This thing is coming up in a big way. So how it is happening? So CIPM has got this one thing which is called SI Digital Framework. So SI is a system of international units, and in this system of international digital framework, we have three layers: application layer, service layer, and the SI core. So how each one of them function is that we have various values and their unit, the quantity in which they are represented, and the uncertainty associated with it. So these value unit kind of quantity, it becomes the part of my SI core. Now, using this SI core, what are services I develop? Some of the services that I can immediately think of is digital calibration certificate. I'm using all these values, quantities, and uncertainties, which the SI core helps me to establish all these quantities digitally. And then with this digitally, these quantities being done, then how I use them to produce a digital service, like a digital calibration certificate is the part of my service layer, that how I design it. And again, various data service and tools. So again, here is something like recently KCDB has given us an API for assessing time. टाइम का एक API है जिसके के अंदर हम usually we put forward our time related data onto this CIP servers and all. So they have KCDB has given us an API. We can use those APIs because till now it was our choice. We use FTP, we use Telnet, whatever type of protocol we wanted to transfer those files to that server. So now they have given us an application program, an interface through which we can write our own programs and transfer these files to those servers. So there are various parts where these service layer is concerned, and again, anything that we deliver through these has to follow this FAIR principle, is what it is called. F for findable. We should be able to find what we are producing. Then it should be accessible to everyone. Everyone needs to be able to access it if they have the correct authorization rights and all. Once assessed, if it is here in system A, if that data is required in system B, it needs to be interoperable and reusable. So these are the basic FAIR principles onto which this grand SI digital framework is now very important. There was this APMP survey on, so this is the international scenario that we talked about. Now coming to our specific region, which is APMP, Asia Pacific Metrology Program. They conducted a survey on digital transformation in 2021 in response to the BIP workshop. And around 600 participants participated in this program. And Dr. Ulrich presented that what is it? And this survey has got various type of questions. And the summary of that survey that came out is that NMIs across APMP are experiencing digital transformation as a challenge. They are not able to understand from where to start, how to start, what all comes under this digital transformation, because everything now includes a computer or a mobile phone. Then it also identified that most of the economies that are in APMP are in a very early stages. And amongst members, there is not a lot of coordination in terms of digital transformation, because we are participating in proficiency testing, round robin testing. कभी भी कोई सैंपल आता है, वो हम लोगों के लिए अगर हमें अपना ये मेंटेन करके रखना है अपना CMCs, then we have to collaborate. There is no other option. You have to collaborate. But such type of ecosystem or environment is not present currently when we talk about digital transformation. Whatever I do, whatever they have done according to themselves. Whatever small services they are providing to their customers wherever there is a need. But whatever they have done, whatever I have done, there is no ecosystem to share all those findings. Another important topic that they highlighted is that there is a low demand from customers themselves for this digital transformation. Okay, हमें भी ये वाली फीलिंग है ना कि अगर मेरा इंस्ट्रूमेंट यहाँ सच में आया तभी कैलिब्रेट हुआ है, मैं वहां से इन लोगों को अगर अपना इंस्ट्रूमेंट एक्सेस दे दिया, पता नहीं मेरे इंस्ट्रूमेंट से क्या डेटा ले जाएंगे, ये सही में करेंगे भी कैलिब्रेट या नहीं करेंगे. So again, customers, they are more or less, but this is, we are talking about APMP, which has got so many economies in it. And it is again in 2021 is when this results came. Understanding what digital transformation really means was highlighted as a problem. In 2021, we were also not very clear कि अगर हम अपना सिर्फ एक ये जो हमारा सर्टिफिकेट है, अगर हम इसको स्कैन करके भी भेज पाएंगे एक पूरे प्रोसेस के थ्रू, तो that is also digital transformation. But another very, very important thing that has been highlighted is we do not have human resource. A human resource who knows both IT as well as metrology. अगर किसी को IT पता है तो पता होगा कि सॉफ्टवेयर कोड कैसे लिखते हैं. लेकिन अभी जब मैं बहुत सारे यूनिवर्सिटीज में भी जाके ये प्रोग्राम देती हूँ, या हम फैकल्टी डेवलपमेंट में भी इस प्रोग्राम को जब मैं हाईलाइट करती हूँ, then you don't understand the metrology part. And after the sessions they come to know, अच्छा ये तो बहुत अच्छा एक प्रोजेक्ट बन सकता है, इसमें हम बहुत सारा काम कर सकते. But again, whosoever NMI who is actually excelling into these digital transformation activities is when there is a strong need from the industry side itself or from the customer itself. If they show that no, we need this, this is what we require, and that gives us an extra push in terms of motivation as well as in terms of gathering the required resources for getting it done, because we don't have people, required manpower to get these things done. And another important thing is when our customers don't need it, when our industry don't need it, we will not get that level of funding, because they say that this is, we may get a funding for research and everything, but again, this is services that we are providing to our customers. So second point is in the APMP survey they highlight is the funding. Third important thing is all the stakeholders. Our stakeholders, you are also a stakeholder. NAPL is also a stakeholder. we ourselves as a stakeholder in this national quality infrastructure, there needs to be a strong engagement of all these stakeholders in order to understand that what this digital transformation is and why it is required. And we all come together. कुछ आपके पास है, कुछ हमारे पास है. Let's make up a team and try to achieve what we emphasize for each one of us. ऐसे नहीं है कि अगर आपने कुछ अचीव कर लिया, it is good you achieved something, but let's help each other. Wherever hand holding is required, let's hand hold each other. Wherever funding is required, okay, let's help out each other. Wherever the resources are required, help out each other to actually achieve what we want to, what we have envisaged for ourselves in this domain. Another important thing on to which the whole international community is working is that there is no clear standards to set expectations here. I have, like, in the coming week, we have two meetings. I am a part of that one meeting, which is with SIP, where the Mexico, Argentina, all these economies participate. Another is with APMP group. So what we are trying to do is we want to make a checklist. A checklist which, suppose I fill it up, that checklist, and I get to know from the score of 0 to 100 where I stand in terms of my digitalization transformation process. Where do I stand on? If I decide, okay, I am at 10%. I am at 20% now. I want to go from 20 to 30 in next 2 years or 3 years. What are the metrics onto which I need to work upon? So it gives you, first of all, हम बहुत सारे कंट्रीज के लोग हैं इस पे जो काम करने के स्टार्ट करने का सोच रहे हैं इस साल से. It's a very tough thing. Identifying those metrics and actually mapping your efforts onto those metrics and giving you a quantifiable result as to where you stand right now in terms of these digital transformation process. That is one thing that we are starting. From next week, we have this very strong brainstorming sessions happening in this trust. Then we need to, again, जैसे मैंने कहा ना, अभी भी अगर आप स्टेशन पे जाएंगे नई दिल्ली स्टेशन पर, तो पुरानी खिड़की के बाहर अभी भी बहुत सारे लोग खड़े हैं. हम हैं, अपना सूटकेस लेके जाते हैं, सीधे घुस जाते हैं. We need to find the balance between the new and the old. And this finding balance between new and old, it depends on our environment, our circumstances, the way our customers want. ये एक ऐसा डिसीजन है जो कि इंटरनेशनल लेवल से नहीं आ सकता. ये हम सबको मिलकर एज स्टेक होल्डर्स नीड टू ब्रेनस्टॉर्म एंड डिसाइड कि हमें धीरे धीरे करके अपने आप को कैसे चीजों को ट्रांसफॉर्म करके किस तरफ लेके जाना. जब हमने IRCTC शुरू किया था, एवरीबडी वाज कंप्लेनिंग कि जब वो एक स्लॉट के लिए खुलता था और जब वो खुलता था तो वो हमेशा हैंग कर जाता था, आप लॉग इन ही नहीं कर पाते थे, आप उसके अंदर पेमेंट नहीं कर पाते थे, पैसा आने में बहुत टाइम लगता था. एंड फ्रॉम दैट स्टेट, if I talk today, IRCTC has expanded itself so nicely. आप अपना LTC का ट्रेन फ्लाइट टिकट्स भी IRCTC से बुक कर सकते हैं. रिसेंटली अगर आपको कहीं पे एक रिटायरिंग रूम चाहिए तो वो भी आप IRCTC से बुक कर सकते हैं. They have partnered with various hotels that if at that destination you want to book a hotel also, that you can also do through IRCTC. Food, they have given you an application where you can book फूड. ट्रेन बोर्ड करने के बाद आपको किस स्टेशन पे किस तरीके का खाना आपको चाहिए, वो आपके ये केटरिंग पार्टनर्स के साथ भी दे हैव कोलैबोरेटेड. सो अगेन इनिशियली वी हैव टू डिसाइड आवर टारगेट्स. 3 साल का क्या है, 5 साल का क्या है, अगले 10 साल में हम सब मिलकर ये कहा क्या करने वाले हैं. सो with all this scenario in 2021, NMI says that they want APMP to play an effective coordinating role as to how we can take it forward. And then it was decided that a focus group can be a meaningful step in this direction. And hence, the digital transformation focus group was formed in November 21, and it is being currently chaired by Dr. Blair Hall, who is from the NMI of New Zealand. And we from NPL, we are 4 to 5 members who are actively participating in this DXFG group for this digital transformation metrology activities. On an average, at an international level, what these other NMIs are doing. So the developing NMIs, they are actually contributing to digital SI, the digital calibration certificates. And again, there are a few who are actually working on to the development of machine learning and artificial intelligence algorithms for this measurement data. And definitely, there is a lot of work going into creating that infrastructure for data and the research data management. Infrastructure in terms of the human resources, IT facilities, and everything around to build these services. So again, this digital SI is something which contains the rules and regulations for the uniform authoritative exchange of measurement data among machines. This is the crux of what CIPM is doing right now, and this is called digital SI. And it defines machine readable data that will, as we discussed previously with this FAIR principles and everything. So with digital SI coming up from CIPM, this was forced, like they have this working model of DSI, which was done by PTB Germany under this European Metrology Program for Innovation and Research. And it is all based on an XML type document. And this is from where this XML being used as a standard for representation of the data came. But at CIPM level, they have still not pointed that only XML is the way. They are still working only on to identifying the rules and regulations. But there is not only one technology that you have to ponder with. So this is how this XML format represents that they have this real as well as the complex values in SI. This is the label. Suppose I say temperature, then the SI value, whatever SI value I want to represent, and the unit is degrees Celsius. What is the uncertainty, the coverage factor, the coverage probability, and the distribution? This is how they are using it for the digital communication. There are many NMIs who are using JSON. There are many NMIs who are using YAML also. And then we have XML. So this is what we call as digital SI applications, which is like smart meter की जगह हमारे पास एक digital meter हो सकता है, DCC हो सकता है, where we have this data formats where there's not only XML, there can be JSON as well. So this is what digital SI talks about. And SI based communication is what is required. हर जगह पे लेकिन अभी भी SI based communication is not what is generally being used. So that's one thing which international community is brainstorming upon. Another very, very important part is this digital calibration certificates. And this digital calibration certificates is something where we do not mean that if this is my certificate, I scan it and send it to you. This is digital certificate. Most of the NMIs are doing this one. They are not actually scanning it or something. They are actually generating the PDF of this certificate. So in DCCs also there are levels. So we call it as level 0. Level 5 तक जाना तो बहुत मुश्किल है अभी. लेकिन level 0 में भी अगर हम start कर पाए, तो that will be big thing for us, so that all the service related things that we have for our customer, they are digitized, and he or she, whatever the industry gets, the PDF security enabled calibration certificate. So, but DCC employs something where this machine relatable calibration information, it can also be comprehended by the machines to establish traceability at a point of measurement. So the aim is to develop universal exchange formats throughout the metrology sector. So जैसे एक फॉर्मेट है जिसमें कि हम एक्सएमएल की बात करते हैं, दूसरा है जहां पे कि आप जेसन की भी बात कर सकते हैं. So this is the basic structure of our DCC. It has got hierarchical structure, and in this hierarchical structure, it has got 3 parts. It is important to understand these 3 parts, 4 parts. One is the administrative data. We will go one by one into each of them. Second part is also very, very important. That is the results of the calibration. Third part is comments, which is again most of the fields, the way they have designed that schema of this digital calibration certificate. You don't need a lot of comments, but yes, most of them are not very much mandatory, and then converting it into a human readable form. Okay. DCC is something, this word is coined by PTB Germany. So DCC, this source is also from PTB. So this XML they have taken it as an exchange format. We at NPLI, what we are doing, I'll just share it with you. And it incorporates all these digital SI things to make this DCC. VIM, GUM, CODATA, and 17025, all these norms and standards are a part of this structure of this DCC. So what all comes under this DCC? So we already discussed there are 4 parts. So let's come to the first part, which is called the administrative part. And it has got most of the information which is very, very important for our calibration certificate, which is like, what is the calibration laboratory? Which one is the calibration laboratory? What is the calibration object that we are working upon? Who is our customer? That name of the manufacturer means the object that has come to us. Who is the manufacturer of that object? What is that type of device? The previous date of that, what is the date of the calibration certificate? Name of the examined device. Then there are measurement results. Again, we have value, uncertainty, coverage factor, unit, and time. Comments is something which gives additional information, and comments are usually optional in nature, and it is up to the author to specify them. Document is something into which our calibration certificate is stored. So recently there are many NMIs who are working on PDF A3 format, which is again a sort of a standard, so that it becomes readable. It is converted into a document which is readable by the humans. And the standardization of DCC, we already discussed that it has got, it incorporates all the things of digital SI, WIM, GUM, CODATA, 17025, and the PTB Germany has implemented it in XML. We can work on to other sort of data exchange formats like JSON as well. Again, a third part that the international community is working upon is this IoT, which is Internet of Things. We currently are only focusing upon this DCC concept, but again, it will work on to this digital SI format to get things done. So if we come to NPL UK, so NPL UK is basically more focused on data analysis and empowering the quality data assessment. They are actually they are actually working onto various AI and machine learning algorithms as well in order to identify whatever data that has been gathered, how to analyze it and empower it for data quality assessment. There is one hand raised, so can the moderators ask what's the question that because I'm not the moderator, so I can't unmute them and ask the question. There's some hands raised. Okay, many. Ashutosh sir, can your team
Yes, ma'am, please.
there are many hands raised. So can your team
Ma'am, I can make them panelists, but what we will do after the presentation, we will make all the participants panelists because we will take the group photographs also to put it on the Twitter channel and other channels.
Okay.
Okay. So my request will be you kindly complete the presentation first, then we will take all of them panelists.
Okay. Start. So the R&D efforts focus mostly in two areas, which is developing techniques to improve modeling and predictions and decisions to be made with confidence. So there they are using simulations as well, and they're trying to analyze the previous calibration and testing data that they have, and then what all can be done in some predictive modeling sort of a thing there. NPL digitalization strategy is basically to update current meteorological service and create new meteorological services where data and data quality assessment are in the center. So that's in a summary is what NPL UK is doing. PTB is again, they are working on DSI as well as the digital calibration certificates, and they have got majorly work into these four areas: digital transformation of meteorological services, meteorology for simulations and virtual measurements, meteorology of communication systems for digitalization, and meteorology in the analysis of high dimensional area. So mostly their domain is very, very large. I got a chance to visit PTB last year, and the number of people they have to these meteorological services, digital transformation, the group is very, very, very huge. And they have got a lot of industry support, government support for these programs. Another important one that is working is this METAS Institute, which is from Switzerland, and they are applying new approaches, new tools. Again, they have used this PDF A3 format with DCC in XML itself. So that's what they are working on to, and then they are working on to this agile methodology for these digital services. It has got dynamic R&D interdisciplinary framework, shortly planned and executed feasibility report. So new research topics come, then they try to do the fast prototyping, like that is what agile is, and then develop potential development opportunities. So that's what the international scenario more or less is. This is how I divided my talk. Introduction part where we emphasize basic terminologies, international scenario, then national scenario in terms of what CSI and NPS work is, and then how we are going about it. So NPL, we have got 6 research departments and 7th is the services department. We all know that it is the Metrology Institute of India, and currently we have got 236 CMCs, and these CMCs are listed at VIP and KCBB, and this is all that we have right now. So as you can see, most of our CFCs are in DC and AC voltage. I'll bring this to your address in next of the slides, but this is what it is, and we are CIPM member state since 11 January 1927, and CIPM MRA since 14th October 1990. So this is what we are. We have 6 different departments which are working into 6 different metrology areas, starting from physico-mechanical metrology, where we analyze the physical units like length, pressure, temperature, etc. Then electrical and electronics metrology, where comes this AC, DC, voltage and everything. Environmental and biomedical metrology, where we have got things like environmental pollution monitoring. We have got this data as well. We are coming up with a very big project of this environmental monitoring and everything at NPL. Another one is this biomedical metrology, where we are trying to develop standards for, and they've started with the ECG devices, ECG as well. Then this materials and device metrology, where we are contributing through core data, and we are developing some low carbon, and we are having this waste material with the economy sort of a thing, where we develop tiles and everything. Then we have got Bharati Nirdesh Dravya, which is called BND, which is nothing but like our Indian thing for certified reference materials. So this is another part that we have to focus when we are designing our digital calibration certificates. And last but not the least is our Indian Standard Time Methodology, for which we are also known as the timekeepers of the nation. And our CMC is one of the best in the world when it comes to uncertainties in time. And we have now got even our cesium clock again started. So this is what we at NPL are. And this is the basic thing that we are primary standards for metrology and traceability. We have got CRMs as well. So this is something that we need to add upon. Lot of international cooperation, and recently in 2021 there is this survey that ran combining all of us as 10, but when it came to metrology we were 22 metrology services. uh, we have very strong basic and applied research coming up to this special pigment for security application, carbon-based materials for strategic applications, one of the best solar cell calibration facilities is coming up this year at NPL, and again the environmental monitoring, data collection and monitoring. So with all these as our strengths, as our resource, as our background, what has happened at NPL right now is that with our directors joining NPL, we have been at CIPM after 23 years. In Indian is there in CIPM after 23 years, who's our director, and he's now also onto the digital SI working group. So as we discussed, they are consultative committees and then they are working groups. And in this working group, our director sir has become a member. Again, he is being elected into APMP executive committee, and that has also happened after more than 15 years. And in APMP, he is heading the digital metrology and the energy efficiency working groups. So we have more and more focus coming onto digital metrology, because now our leadership is present into these working groups, into these executive committees, into these consultative committees. One of these consultative committee on mass, where one of our scientists, chief scientist, Dr. Titus, is heading this consultative committee. We have a lot of staff members which are working on to various technical committees of APMP and CIPA. And as I already highlighted, that we are very active members of digital transformation focus groups. So with all these coming up, this is what we are doing, and we need to adopt these globally established and proven techniques of digital metrology in Indian countries. Whether we should do it, whether we should not do it, how much we should do it, what all should be the things that we should prioritize first, what can be taken up in a later phase. And with all those inputs that we have come upon, we have identified that we will start with this digitalization of DCC, like calibration certificate, at end. So what is it that currently we have around 236 CFCs that are there, but when we say that from one end to another end, so we did one more survey within our institute to identify when we do our calibration, how much of those activities involved in that calibration process are actually automated. That too specifically in CMCs. So we find out that 20 to 30% of the processes uh, are actually automated. But and now we have these efforts to convert these XML, these calibration certificate information into a DSI XML form. So we have worked on to, as I highlighted previously, that our CMC is mostly for DC and AC area. So we started with DC reference standard, and recently we have converted this stopwatch calibration data also into DCC DSI XML format. As we can understand that once the certificates are generated, security is important. So we are even started a project for this development of a portal enabling role-based archiving and access control. Again, utilizing open source identity and access management. Recently, we have some of our papers have accepted in OC Gas, so we will be presenting our work at various international forums as well. So this is the status of our current CMC's automation status, where we have DC voltage meters, time and frequency, whether none of them is completely automated, but what we could see is that they are partially automated, or how no automation is for which things. Then if there is an automation software used, what is the type of automation? Now here you can see that the automation software used are very different for each of them. Hardware requirements, again, some are using RS-232 interface cards, USB protocol or IEEE 488, and then measurements are also automated, and then once the measurements are done, they use their written program, or they use Excel for that uncertainty estimation. And once that uncertainty estimation is done, then the completely converting, giving all that data to a calibration certificate is again a completely manual process. So this is few of the examples that I have collected from that survey. Again, if you could understand that once this calibration, it includes a number of steps. So what are these steps is emphasized characteristics of the DC is that free of change in used media. मैं ये use करूँ, ये use करूँ, ये use करूँ. It's all the same. Then machine readable, where we have got this measurement uncertainty, data represented in particular units and everything. And then machine interpretable is something that we have called upon. And in machine interpretable, we have talked that it is has to be uh, operatable and interoperable, both times. And then again, findable, accessible, interchangeable, and reusable. Those fair principles that we have talked. So, aim of the application of digital calibration certificate is automation of the processing of the calibration system. The complete processing of calibration certificates need to be automated. So, how are we going to do it? I'm unable to move it to me. Oh, yes. So, do we need DCC? More or less, we identified within ourselves, and there were various metrology contexts that we kept on happening. Admit is there, where we conducted a few questionnaires and surveys, and then we got an answer that yes, it's required for us. Because there is a lot of digitization at customer end. Without the whole this calibration certificate is one of the major important services that we are providing to our customers, and without this the orders or the requests that we are getting, they may get lost. So there is a very very strong demand for this. And integration of raw data, pictures, data sheets is something that is work under progress under DCC at an international level also. So we may try to get this into picture into course of time. So what is happening is that there is a startup calibration, then we do data logging. So in our case, it can be Python. We saw that it can be done through MATLAB, it can be done through LabVIEW, in any possible language. And then once this data logging is done, then there is this analysis of this data that is done to another software. And then finally, we are coming for uncertainty estimation through Excel and everything. So this is the whole workflow. And now this calibration certificate is generated completely in a manual. So this is how it is being done right now in our organization. We start a calibration, we use some automation level to get the data logging done. Then once the data is logged, in order to analyze the data, we will use another software, and then with all those softwares we get what is the uncertainty of the data, and then we create a calibration certificate for our users. So this part, we are not right now asking all our researchers to have how are we going to have this part included. Like this is what they are doing with different types of softwares and everything, and we are not interfering anything as far as this is good. We are only focusing on to getting this digital calibration certificate. So as we know, this digital calibration certificate is where we are transferring it into an XML with these three parts: administrative data, results of the calibration, and then comments part. So all this data is already here. Now we have to convert this data into an XML format or into a JSON format to get my digital calibration certificate. So how are we importing this calibration results is what is important. So in order to import all these things into my XML format is where I am developing a middleware. So this middleware is something which is sort of a solution where you simply enter the data and it automatically converts into that required XML format, so that you don't have to do anything. There is this middleware, you enter this data into this middleware. Even if you don't enter this data, that is not the possibility right now. We have developed a UI user interface, web user interface, where you enter whatever data you want into which is the required fields of our DCC, digital calibration certificate, and then it gets converted, dividing it into the administrative part, measurement results, comments, and documents. So this is one level of advanced. We get this machine readable. This is where our part is. We developed this middleware. We got this machine readable format data. Now we need to develop another middleware which converts it into a human readable document. So these are the two level of middlewares. This is the approach that we are using to develop our digital calibration certificate. We are developing two middlewares to get a human readable calibration certificate. Once this calibration certificates get generated, then comes the review process. Until unless this calibration certificate in human readable format is not reviewed and approved, it has got no value. It is simply a piece of paper. So, instrument audit trace needs to be there. But again, we are not going towards that instrument audit trace. We are only and only once they have done everything onto an instrument, they have given us the results, is from where we are bringing ourselves into picture. Because we need to break, as I already said, we need to have this modularity into the task that we are doing. We cannot do everything at a one go. We get data from our metrologists, from our researchers, from our scientists, from our operator. Once we get this, we convert it into an XML. We develop another middleware which converts it into a document. Then it goes through that review cycle. Once it is reviewed, then again, okay, we again transfer it into an XML. Now we apply all those. Only the certificate. Again, what I'm trying to say is the digitalization process is not simply a certificate that we are talking about. Here it is all about that data that we are talking about. See, if I again create this document directly, I can do that. But then that data which I am keeping it here, it is not interoperable with other instruments or with other devices that may be working. They may be storing data in some another format. So they also need to bring it into a format which is interchangeable. Flexible is nothing but the way I am keeping my data. And again, here we apply our security and everything. And again, this is something, once this is okay, then it cannot be changed. Nobody can change. But until unless it is not approved, it is not completely certified that this is the calibration certificate is all okay. We have no calibration done by, checked by, reviewed by. These are the three or four levels of. So again, you can develop these DCC with its middleware. You can have various full stack development technologies comes into picture. So we have so many, there is plethora of technologies available to develop any application. So if I'm developing 2 or 3 middlewares, what is the technology that I need to use and how to get it done? So here are some questions. A simple introduction is that when we are talking about full stack development, it is development of the front end as well as the server side part, the back end as well. So they design, the full stack developers design the complete web applications and websites. They work on front end, back end, database, and debugging of web applications. So they are highly skilled developers that we see to it, and they work for front end. So actually, we need a full stack development only, where we develop a middleware which provides web-enabled UI to our end users, to our operators who are actually doing the calibrations. to put the result onto those UIs. Again, how they are going to access those UI once they have entered all those data into those UI, that goes into the person to whom we assign that, okay, for this calibration in our 17025 we identify now for this calibration process, these are the operators. In case this operator is not there, who is going to be the secondary person or the backup person who is going to come up and who is going to review these things. So these has to be actually maintained through our digital through our application itself. Then once it is done by checked by, then reviewed by the head of the department and everything, and then finally signed by the head of this calibration. Yeah. That is what we are trying to do, that the traceability of instruments that is coming to, all that information is actually embedded into this calibration certificate. Which instrument we are talking about, what is, when that the instrument with through which it is getting calibrated upon, when that instrument was calibrated, what is its uncertainty, what is the data that they have gone when they were trying to calibrate this particular instrument, what is the data that is there, how they have achieved, once they put in that data and they identify what is the coverage factor, what is the distribution, then we can even give them a uncertainty calculation also, the uncertainty graph also we can embed. So these are n number of parameters. The more number of parameters we try to automate, the more complex it gets. So in order to understand that we have to do everything, but the architecture with which this whole middleware needs to be designed, it has to be very distributed and interoperable and modular. So that is why we work on to this Spring Hibernate MVC2 architecture, and I have always worked with Java platform, so that is what we are working on. But you can have the whole front-end technology, the back-end technology, the APIs that you want to use, the software versioning control that you have to use, the algorithms in the data structure that we want to use. Again, as Sir said, again, if I want to use blockchain because for these DCCs, that also can be done. But again, we have to start deciding up. We have to start experimenting with what we have. At least deliver something to our end users and then start progressing on it. Rather than in the initial stage, we decide something very, very big and then we are not able to deliver it, then I don't think that makes sense for me. So there is, like, which technology would you like to use? There are many technologies for front end. So any idea, you people can type into the chat box which technology we can use to actually develop the visible part of the website or the web application, which our operators, the actual calibration people who are checking it can actually, okay, .NET MVC. But .NET is again old technology. But and MVC is again model view controller architecture, as far as I know. MVC2 is something, 3 is something has come up. Now, my question is, what are the front-end technologies that we can use? Name few front-end technologies that you may be aware of. Something like HTML, everybody might be knowing. हम हर दिन यूज करते हैं अपना कोई भी वेब पेज डिस्प्ले करने के लिए. अगर उसके साथ में इफ वी कैन ऐड अप जावा स्क्रिप्ट और एजैक्स उसको एक फॉर्मेट में लाने के लिए, सो देन अगेन फ्रंट एंड इज समथिंग. HTML definitely can be used for making up these web pages. Then CSS, definitely we need CSS to design these web pages. There can be JavaScript, which is again used for making the site interactive, which actually helps us ensure that the field which is written there, the user is entering the correct type of data into that field. Again, how we store these data is again a big question. You cannot, if you store XML, it takes a lot of space into your database because we're storing, if we are storing along with its structure. So that's another type of question that may come up. And then how you design your backend controller and model is, again, you can use PHP, you can use C++. We are using Java, and another project that we are taking up is that will be in Python, where we'll be developing some machine learning modules for our database. So these are some of the popular stacks. Python can be used. So we have mean stack, which is MongoDB, Express, Angular JS, and Node.js. I don't think we need to go that deep. This is becoming too technical now, I think. And again, we may have various type of databases to store this thing. So I prefer these. I'll ask you these 3 questions, and if each one of you can write down something and send us into the chat box, that will be great. So how can digital technology transform measurement services delivered by these metrology institutes? What new ways do you think are there to obtain and analyze this measurement data? And last but not the least, how can metrological information be shared to promote innovation? If I have this information about these measuring devices, I have this information, how can it be shared? And that helps in improving the innovation. I'll have a 5 minutes, like where I would like to see something in the chat box where you actually start writing, and that is more or less coming towards the end of my third segment, which was like what we are doing as an NMI at NPL. And last but not the least, what is our strategy? So we are targeting this DCC implementation. Then again, measurement process automation is something the scientists in the respective groups are taking care of the way they want to take it up. And again, the whole services part, the customer interaction portal and everything, that is the third department which is taking care of. And again, you see, within an organization, one person, one department cannot do everything. So again, here also, different people are responsible for different tasks or activities that we have identified. They're working into their own pace, but in the end, the architecture or the way we are developing the software should be such that all this data is interoperable. We can seamlessly assess it and integrate it wherever required. So for all these things, we are developing our development environments, infrastructure development. Oh, okay. So you are only using, no, but that VLOOKUP is very yeah, okay. SQL tabulating, okay. And then we are deploying a server-based portal for entering this calibration certificate data and measurement results. And it will again have this role-based access control and archiving. We are initiating it with a pilot project. So sometime next year, this portal, we will be launching it for our departments. And this customer portal to serve the request of the customers is again being handled by another department that we have. So steps are many. and we are having this high. Yeah, you found it on Twitter, but that's different, you know. This digital calibration certificates, I, as an industry, I come to you for my calibration certificate, and I should, I may not be very much comfortable. Like in Twitter API, we have this facility where I can search anyone, I can see the profiles, they might have logged it, but that's the whole idea of Twitter. But that's not exactly the way the DCC is. DCC is more or less like a, you have a digital, you have a notarized certificate. So digital notary is something which may be something like, okay, oh great. So having a repository and then using it at an international level where internationally that data is accessible, interoperable, is what right now the focus is for NMI, for NP India. Yeah, sure, I can. We can even collaborate. You can call me, you can email me, you can really talk and decide how to develop these middlewares. So basically, there are many security features. Is something like I have recently started working on to the security features because nothing works without security as far as this this type of environment is concerned. So I'm looking forward to people. I'm not next session anything possible. Okay, I don't know. But I am really looking forward to people who would like to work onto this security aspect of this calibration center. We are in the process of having MOUs with different academic universities as well. But sorry to say, the type of manpower we have, the engineers we have, they don't have, like, we need to actually groom them a lot. We need to actually skill them a lot. We need to train them a lot. Yeah, digital signature is mandatory of the people who will be like जिनके साइंस से बाहर जाए. It again depends. ये business process engineering का भी एक part है हमारा. So again, challenges is large amount of data that is stored in various type of formats. There is sensitive manufacturer data. It must be protected against unauthorized access. And we have research collaboration partners. We need to have a policy which grant access to these joint documents, which currently is not in place. So we really need a competent team with required skill set, long-term strategy with time-bound goals and activities to be laid out. It involves various stakeholders and the coordination interfacing among these various departments to resolve various functional and technical issues is actually very important. अभी एक ये माइंडसेट भी है कि अरे क्यों करना है मैडम, क्या हो जाएगा. So that mindset transformation and like today's program where we try to create awareness. Yes, the output data will be in downloadable. The output data is going to be in that interchangeable format. Yeah. I'll just go to that slides also. मैंने सोचा था वो slides दिखाऊं ना दिखाऊं, but I'll show it. So there needs to be this awareness programs where we talk about this digital transformation and topics like this. Internal awareness program where we address the queries like why it is required, how protection against. आपके यहाँ QR code. Okay. But how are you designing that QR code? What are the parameters onto which that QR code is designed is also very important, I suppose. How protection against unauthorized access will be ensured, and then there are variety of software data stored in in umpteen formats, and so that's why we are developing different middlewares to get it done. So way forward, we all have to work together more closely, and not thinking मुझे क्या मिल रहा है तुम्हें क्या मिल रहा है, more or less to get things done. This is the task that we have identified. Let's get it done. So area where I am looking forward is this digital calibration certificates. This is our next 3 years roadmap. So in summary, we have to work in a collaborative manner to ensure proper and quality assured digital transformation. Otherwise क्या होगा ना, आपने कुछ बना लिया, आपने कुछ बना लिया, सब साइलोज में कर चल रहा होगा, लेकिन एंड रिजल्ट वही होगा कि फिर भी हम स्टार्टिंग पॉइंट पर ही खड़े होंगे क्योंकि आपस में कुछ नहीं चल रहा, तो उसका कोई फायदा नहीं। हम सब कोलैबोरेट करके बात करके कि स्टैंडर्ड तरीके से आगे जाए, तभी पूरा नेशन आगे जाएगा, ऐसा मेरा मानना है। These are some of the references. अच्छा, अगर आपको ये कैलिब्रेशन सर्टिफिकेट और डीसीसी का एक हल्का सा आइडिया चाहिए था, तो जैसे हमारा जो सर्टिफिकेट होता है उसके अंदर हमने कौन सा सॉफ्टवेयर यूज किया है इसको बनाने के लिए, वो पार्ट होता ही नहीं हमारे वाले कैलिब्रेशन सर्टिफिकेट में, या जो हमारा कैलिब्रेशन सर्टिफिकेट का एक फॉर्मेट भी होता है उसमें भी नहीं होता। बट इन डीसीसी वी नीड टू एंटर ऑल दीज software that has been used in order to make this certificate. तो अगर जैसे आपने विजुअल स्टूडियो यूज किया है, आपने मैटलैब यूज किया है, इवन अगर आपने एक्सेल यूज किया है, अगर आपने 4 से 5 तरीके के सॉफ्टवेयर एक ही सर्टिफिकेट को बनाने में यूज किए हैं, तो वो आपको डीसीसी के अंदर यू हैव टू गिव कौन सा सॉफ्टवेयर है, कौन सा रिलीज है उसका, बिकॉज रिलीज के साथ भी बहुत सारे सॉफ्टवेयर में पैरामीटर्स चेंज होते हैं जो कि आज की तारीख में वी आर नॉट कंसिडरिंग देम, बट दे आर वेरी इंपॉर्टेंट। ठीक है। अनदर पार्ट इज जैसे ये मैंने ये हमारे यहाँ का जो एक सर्टिफिकेट है उसको, जैसे ये हमारा एक ऑर्डर नंबर होता है कैलिब्रेशन सर्टिफिकेट का, तो यहाँ पर उसको हमें एक यूनिक आइडेंटिफायर के नाम से देना है। इस यूनिक आइडेंटिफायर के नाम पर भी internationally there is a big research going on onto this unique identifier. The reason being, जैसे it has to be something like a DOI, जहाँ पे हर एक पेपर एक DOI डिजिटल ऑब्जेक्ट आइडेंटिफायर के थ्रू मैप होता है। क्यों? क्योंकि आज की तारीख में ये NPL का कैलिब्रेशन सर्टिफिकेट है, लेकिन इंटरनेशनली that is also a point. Very good. How are we going to validate the software which we are using to design the DCC? We have to. There is no other option. And then जैसे यहाँ पर हमारा पूरा मतलब किस दिन हमने कैलिब्रेशन स्टार्ट किया, किस दिन एंड किया, कौन सी लोकेशन था, उसका नाम क्या था जहाँ पे कि हमने ये शुरू किया, ऑल दीज डिटेल्स आर देयर इन डीसीसी। अनदर इम्पॉर्टेंट पार्ट इज ये जैसे डिस्क्रिप्शन और आइडेंटिफिकेशन ऑफ इंस्ट्रूमेंट इज अनदर इम्पॉर्टेंट पार्ट। ये हमने एडमिनिस्ट्रेटिव डेटा में डिस्कस किया था, जैसे कि ये मेरा एक डीसी रेफरेंस स्टैंडर्ड है, इसका ये मॉडल नंबर है, ये सीरियल नंबर है, ये मेक है, ठीक है, और ये ऐसे इसके अंदर जाता है। स्ट्रिंग मैन्युफैक्चरर आइटम क्या है, कस्टमर का इक्विपमेंट नंबर क्या है, उसका आइटम नंबर क्या है, उसका सीरियल नंबर क्या है, all these details is how this is I'm showing the XML part. Then again ये सारी डिटेल्स हमारी जाती है हमारे हेडर में ही होती है कि ये एड्रेस क्या है हमारा, फोन नंबर क्या है, ईमेल क्या है, सो ऑल दीज डिटेल्स कम हियर इन DCCL. ठीक है। Then these are the sign that we have calibrated by, checked by, scientists in charge and issued by. So ये जितने भी responsible persons हैं उनके हमारे signatures होते हैं, और यहाँ पे उनके हमारे digital signatures embedded होते हैं। So अगर जो भी हमारा कस्टमर की जो भी डिटेल्स है वो भी इसके अंदर जैसे इसमें जाती है वैसे इसमें जाती है। नेक्स्ट डेट ऑफ कैलिब्रेशन और वो पूरा इसके अंदर हमारा डिक्लेरेशन नहीं होता, यहाँ पे एक डिक्लेरेशन वाली चीज भी है, और जो भी उनका नेक्स्ट डेट ऑफ कैलिब्रेशन है वो भी इसके अंदर जाता है। एंड देयर आर दीज मेजरमेंट रिजल्ट्स। तो हम लोग का जब मेजरमेंट रिजल्ट्स लिखने की बात आती है तो हर एक के पास एक तरीका है अपने तरीके से लिखने का। इंफॉर्मेशन वही है, that here they have written it in a textual format that has been calibrated by comparison. तो यहाँ पे स्पेसिफिकली हमें अच्छा सर्टिफिकेट्स कैन बी डाउनलोडेड, आई सपोज दैट इज व्हाट यू आर वी डिस्कस। मेरे को लग रहा है अभी ये मैं जल्दी जल्दी रश थ्रू करती हूँ, देन वी विल हैव दिस डिस्कशंस बिकॉज दैट इज व्हाट इज मोर इम्पोर्टेंट आई थिंक। तो ये आपकी सारी की सारी मैपिंग यहाँ पे है जो मैंने दिखाई है आप लोगों को। decision rules are, DCC simply are converting it into a normal open standard format. Then decision rules is all about you make another layer onto what all type of services that you want to operate upon onto that data. That's up to you. तो ये हमारी जो environmental conditions होती है उसको हमें ऐसे लिखना है, and then temperature, humidity, nominal value, measured value, and these are our uncertainties. So that's it. Now we have, I'll stop sharing now. And
Thank you. Thank you very much, ma'am. It was a very good interaction. Actually, now I think we are somewhere able to understand what is this whole structure of digital calibration certificates. It was very good. Thank you. And certainly, I would like to request you to kindly share your presentation so that we can share it with all the participants. We are having large number of participants, 250 plus, so we can share with all the participants, and it will be a very good idea to understand. Now, my request is why we are not thinking to develop something, because India is basically leading in the software part all over the world. So why we are not thinking to have a platform wherein we can develop some softwares or something which are easily available free of cost on the Google app or somewhere. Anybody can download and can start doing this type of exercise. We can think of it. The good organizations. Yeah,
sir,
we have the professor from.
sir, what
Please.
we try to do is that we try whatever we develop, we upload it on GitHub. GitHub is again an open source platform where we develop and we give the code as well. So then they can download it and start. But again, a better idea would be that we make a project where we identify who all is contributing. We know what is their role, and we start collaborating with each other. How it has to be.
Yes,
That
yes.
would be very good ideas. No doubt.
Thank you very much. We have with us our Shri B.N. Dikshit sir. Sir, would you like to speak something?
सर हमारे सीमित थे शायद जितना
जी,
मुझे
जी,
याद आ रहा है.
जी.
So Madam Anjali has given the very beautiful lecture, and it is very thoughtful, and people may think on this very topic that she has given so lengthy lectures that a lot of questions are coming from all the slides. So whatever our students and officers are there who are attending this very program, they can learn those very things, and they can think that how to develop a software, because whatever the software has been developed, and how she has given the script of that. So there is only one background, and with that very background, if you can learn that how to start the software, I think you can develop it. So this is my ideas. Thank you, Madam Anjali.
Thank you, sir.
And Ashutosh is great, Jai, and he is always making program on Saturday. without fail. And that is good for the industries, student, and the government of organizations, government offices, those who are participating. I think all are getting benefit. So again, thank you, Madam, and
Thank,
thank you,
Thank you.
Ashutosh.
Thank you. Thank you very much, sir. Thank you for your kind words. Certainly, this is only possible with the help of all these experts who are available in the field, and we are taking their help. They are very kind enough to take to consider our request and give these presentation, these lectures on Saturdays being holiday without paying anything. They are not giving anything to any of the scientists. It's a great achievement for the country if we are doing like this, sir. My request is there are large number of other participants who are having very good experience in different fields. If you can kindly share your views or share your presentation, share your ideas, share your experience with others, kindly let me know through WhatsApp on my number, because it is available whenever we are issuing a flyer. So my request is we can take more and more experts in the field. Sir, now I would like to request all the participants to kindly switch on your video and switch off your mic so that we can take the picture for uploading on the Twitter handle, WhatsApp and Facebook. And you can you can see your photographs over there that you have participated in this program. I'd like to request all the participants to kindly switch on your video, please. We have with us Professor Rajput from IIT. From IIT, Professor Rajput. Sir, would you like to speak something, please?
Yeah, namaskar, Ashutosh ji. Very good
Namaste, sir.
morning. And Anjali ma'am, your lecture was amazing. And in fact, I have personally just now messaged Ashutosh ji that we need to talk to her with her whole team to come up with some new ideas and products. In fact, your lecture was very comprehensive. And I really believe that some training for other industry people, how they can actually incorporate such thing into their regular practice, and their hell holding can be of good help. So maybe we will discuss it further and take it forward.
Sir, we have already taken NPL in our that national program which we are basically planning to have this
Right,
one
right.
system, to have all these certificates and the software or a portal over which all the certificates can be uploaded, maybe with other departments also. So I hope that we have already requested Director NPL last week I met with him and ma'am. So I requested them to kindly be the part of our group, and next time when we will be having the meeting, maybe in the next week, they will be also participating in our group. It will be a good idea. We have to work together at the national level so that all the departments, all the industries can have their certificates in a very easy form. We just have the data. Data can be directly converted through XML or through another software, another language in a form which can be readable manually as well as machine. And then the certificate can be developed, which can be uploaded on the blockchain technology. So this is the basic idea behind this, and all the I hope that very soon within a year, because India is leading in software, and I hope that within a year or maybe 6 months we will be at some level. We are expecting, even when we were in the OML meeting, we have told this to the other counterparts that we are developing this and we will take all of them together in due course of time. This is a small activity which we are trying with the help of, with the support of all the participants and obviously the experts which we have. Thank you, sir. And Professor Rajput Sahab is here. I would like to request you, sir, next time kindly give us, as you have already given one lecture, my request will be you kindly continue to share your experiences with the new generation.
Sure, sure.
Thank you. Santoshi, will it done?
Sir.
Thank you. So with this, I would like to thank all of you, especially Sharma ma'am, who has given this very good lecture, and Professor and all the participants, Professor Rajput, Dikshit Saab. Thank you very much. Thank you all. Thank you. And IC team who has made this program actually successful. Otherwise, it is not possible. Thank you.
Thank you, sir. Thank you.